great for getting your app up and running. It has tools that when your data changes, it automatically updates the UI. But in some cases, once your app gets more complicated, and maybe you do more intense work, in some cases, maybe you work with large images, you might notice a performance drop. Your app is not as responsive anymore. Maybe your animations don't work properly anymore and they're starting to stutter. This is then definitely the time to look into how to improve the performance of your SwiftUI app. So far, every time I made an app with SwiftUI and it got more complicated, or I then finally used it myself with more data, I oftentimes hit a point where the performance is influenced. In this tutorial, I'm going to show you data flow. I'm going to use the app that you see here. And we're going to analyze this, what views are refreshed and why they're refreshed. And we're going to discuss multiple different solutions to improve this. In order to analyze your app and to find out what's going on, we need to use different analytics tools. One of them is instruments, and then we're going to some print statements and some visual helper views. This is the second part of a tutorial where I talk about performance and issues with SwiftUI. And the first part of the series, I talk more about these instruments and how to analyze your apps. So if you haven't already watched this, go ahead and check it out, especially if you're rather new to Xcode and you haven't done any analytics and you haven't used instruments before. Okay, first I'm going to show you the example app, then we are going to analyze what's going on, which issues we have, and then we're going through 3 different strategies, being reducing dependencies, using view model wrappers, and the new observation feature. And then lastly, because this is a rather simple example, and especially if you go for a more complex app with a lot of views and things that could update, I'm also showing you one of my more complex apps. So I'm just going to show you some of the measurements of instruments for this app, so you see also some more complicated data. Okay, let's start by having a look at the demo project. You can find the link in the description box where you can download this, and also then the final version with all the improvements. So you can do all the tests together with me. I have in my project 3 folders for view, view model, and model, and some helpers we are going to use a little bit later. Now, because I want to use multiple different versions of the same app, I have here in this one file, ObservableObject example view, one main view with a H-stack. On the left side, I have a list with, I need to go on the selectable preview, with these raw views. This is the one sub-view I have down here. This is using images from the assets catalog and a little bit of text. I have here also a button where I call a function in this one view model that we have. So this raw view has 2 dependencies. The inspiration data, this is a struct with these 4 properties, name, image name, and description, and ID. And the view model is initialized in the ObservableObject example view. This has 2 properties, one time this data array, and the other time I have here a date property. As you see here, this is this one function that actually doesn't do anything in this demo project, but a lot of the times you have functions that you want to call in the view model. So calling them from a view button or on a peer is quite common. Or maybe you do a task with the new async await. The other thing I added here is a function toggle timer, which starts this timer and updates it every second. So these 2 properties are used in this list. This is the array that is used. I have here then another array where I actually can change this data. So I can change here the title and it updates here. And this H-stack down here, I have 2 things. I have a add more button and this toggle timer function. So this is the one I just showed you that starts the timer. This property, the timestamp, time remaining, is then used in another text field down here. So I have now these 2 properties, the data array of this model data and the timer that is in this view model, and this data is manipulated from different parts of my app. As you saw here, I can change the data array with the title. I can add more and add here new entries. I can start this timer that then is used down here. This is very common. You have a view model with data and functions, and these data is then used in multiple parts and multiple subviews of your app. Obviously, this data needs to be updated. When I add here a new row, it needs to be shown. When I change the title, this needs to update. This then also needs to propagate to other parts of the app. And I use ObservableObject to do this, passing through this data. Now in this case, I actually do a little bit too much. And in order to see this, we're going to start with instruments. So I go under product, profile or command I. Every time you do a change, you need to run this again. I get the template window in instruments, and I'm choosing the template for SwiftUI because I want to know when the body is invoked, so when views are updated and refreshed, and why they are doing this. I can now start this measurement for Mac. Now I can interact with my app, and in this case, I'm going to add one more row here. I'm stopping now, then I zoom in with a pinch gesture, and then I am selecting the time where I actually tapped on this Add More button. Down here we see the views that were updated. Either you choose SwiftUI, this is the SwiftUI internal views. For example, we see that we have 5 times a button. And then the other one is for your own app. So this is the name of my project. And the do custom views, I only define 2 views actually, and I only use 2 views, so that's why we have them. For the example view, I have a count of 1, so this was recreated 1 time, or the body was created 1 time, and the raw view's body was called 5 times. Now I only added 1 raw, so it's kind of weird. I should actually only see here 1. Then the next column is the time duration. This is telling you how long does this take to work on these views. It's usually a good idea to check this column first, so you know which views are costing you the most. So you would optimize and you would check, oh, I have one type of view that takes 5 milliseconds, so a lot more than this, for example. And this is because it was created 10 times. I don't need 10 times, I only need 1. So you can search for the views that cost you the most in the beginning and then optimize them for data flow. In my case, I see here, okay, I have 5 times this raw view called, or this body called. I only added 1 of these raws, so I actually don't need to add so many. Then I go on the view property lane to see what caused this. Now I already said the views that I care about is this raw views. The first column is again the modules, so I sort by module to see which of my custom views was actually worked on. Then we see the view types, or which views were redrawn. Because I don't have here a lot, we can directly see our 5 times raw views. If you have more, you can also use search. We see now I have this raw view. And we also see that we have here worked on a SwiftUI list that uses this type, or this view inside. You usually see here this nested type. So this is a list with it for each that uses an array of my data that uses a subview of raw view type. The next is property type. So what property caused this view to update? And you see here I am updating because my observed object of type inspiration view model changed. And the last column is what is the new value? Because this is now a view model, it's a little bit more difficult to see what's going on here. But in this case, you see that I have a dependency from my raw views of this observable object for my inspiration view model. This might be a little bit overkill because I don't need a whole view model for each of these rows. Now, if I go back to my project, I have here this list with for each, as I said, with raw views, and I pass the whole view model. And because something in this view model changed, one of the properties changed, this array of data changed, this body is called. Initially, I have 4 entries and I add 1 more, so my array is 5. And now it needs to call all 5 rows because of this dependency to this view model. Now let's do another test. I change here the title of one of these entries. So I just cut something out and we stop. I go again to this area and the view body to see. And in this case, okay, my example view changed. And again, I have here an update for raw view types, but 4 times. You saw I only actually had to do this in the row where I changed the title. So I should ideally see only 1 of this raw views update. But again, I see 4. If we go to the view body properties, to raw view, again, I have here a dependency for this raw view to this inspiration view model. This is because the data that changed is an array of structs. If one property in the struct changed, the whole struct changed, the whole array changed, and this property is changed, so my observable object changed, and I get here this update to all of these 4 rows. Let's do another one. I start here this toggle timer. Let this run a couple of times, so it updates this one view down here. So this is the only one that it needs to update. I stop the measurement, and we see here every second there is an update happening because my timer changed. So after 5, 6, 7, 8 seconds, now I select here one of these timer updates, again in the view body. Looking at my project, my example would change. It should change because my text that uses this timer actually changed, so I would expect this is a good update. But I again have here this 4 rows updating. Every time my timer changes, I see here this 4 rows updated. Go to the view body property, again to one of these raw views. Again, it's a dependency to this view model, because this view model has 2 properties. One is this data array and the other one is this time remaining, the date property that changes every second. Because this property changes, the observable object fires one of these object will change notifications, and all views that use this view model will evaluate their body. So because I use this dependency, because I say here this view depends on this view model, this body updates. We can also see this with one of the other tricks. For example, if you want to run this not in the instruments, you can use let underbar and then capital self dot underbar print changes and then run this. Now you see the print statements down here. I have 4 times this raw created, which it should because we are initially launching the app. I'm cleaning this. Now if I add here 1 raw, I get a new error message, which I will have to look into later. But I have here also 5 times the raw view called. So every time the body is called, so every time this view needs to refresh, we go through here and we see this print statement. So we see the type of view that was updated and why. For example, the one that I created new has here an identity. So a new identity means it's the data that it's identified with, which is my inspiration. This is because it's used in the for each, and then the data and the views are associated with each other. So because of the identity is changed because it's a new raw in this list, we see updated for this raw. And then I have 4 times a raw view updated because the view model changed. So you see here underbar, this is a SwiftUI handle data flow instance, and the name view model is printed here because it's the way I call this in this view. So I know, okay, because of this view model dependency, I see here my views were updated. This print statement strategy is now good because I know which view I actually to look into. So we can faster here iterate, change a little bit the code, and then see, do we still have so many updates? The last one that we had was to use a random background color. This is another function that I added to this project where we basically create a random color. And if I do this, I even see the change here because every time this body is recreated, it will call it will again go through this body and it will call here a random color. And then we see a difference because it's every time random, it's a new one. Initially, we have this 4 colors. I add here new. I get this new raw, but all of the other cells also updated. We know which view to work on because of this dependency. Okay, now let's work on the first strategy to improve our performance, which is reducing dependencies. As I said, we know because I'm relying here on this view model, this view updates, even though the property that updated in the view model is actually not used here. So now let's find out what I actually need for this view, since I don't need all the properties. So I copy, find, and I see I actually here only call this view model this function. So now I need to pass a closure for this function. So this is fetch more data. A closure is I don't pass in any data and I don't expect anything back, so it's return type of void. I remove the dependency to this view model. Now for this button, I call this, we cannot also write this a little bit different because I have the same closure type. Now I write an initializer so it's nicer with the escaping closure. And I already here added this escaping. Now it complains because I didn't use this raw view anymore correctly. So this is raw view. I still pass in the one inspiration this view needs, and I pass in here the property or this fetch more data property. Okay, now that we have these colors, we can also use this here in the preview. Or if you go in the debug under preview, you will see also these print statements. So the test was with add more. We get one more raw. The other ones didn't change. This is also now true when I start my timer. The timer updates, but these raws here don't change their color anymore. So this is great. The simple strategy of I only pass into this view that is expensive. This raw view is expensive because of these images. Only pass in the information it needs, which is here this function call. Now, you could further do this. For example, I pass in here the whole nature inspiration data. Maybe I have here a very complicated struct with a lot of additional informations that I don't actually display here. For example, let's say I only show here these images and not actually the title. In this case, if I change the title for this raw doesn't need to update if I don't actually use it. Let's make this a little bit more clear with another subview here. So let's say I have a different versions where instead of this raw, I only have a image. I'm using file private because I'm going to have other versions. Struct inspiration image. This is the view. So if I now would pass in here the whole inspiration to show this one image. So let's say this is the data that I wanted to use. Pass in here now this data. And I should also add a color background. You can also use a list raw background color .random to see when these are changes. Okay, now only use here these images. If I change the title, the first raw also updates because one of the properties that is used in this struct updated, so the whole struct is new and the whole body needs to be redone. So instead of passing here everything, if I want to prevent this updates, I only pass in the data that it needs, which is the image data, which is the image name string. So now I only pass this here and giving the image name. And the name is also now different. Image name, the image name. Okay, now when I change here the name of one of these data entries, the list doesn't update because it doesn't use any data that changed. So you can continuously look for what dependencies do I need to remove. These problems, having too many dependencies, is especially true if you have a view model that is used in your whole app. Maybe you put it in the environment. Let's say I put now this view model in the environment. This is environment object, view model. And I want to show this timer also here. So in this case, because I need to show this timer, I would again use here environment object var view model of type inspiration view model. Because I now use this view model in this images. If I change the timer, again, I have this updating here. Every time you declare this, it is a problem. However, it has also the advantage that you can just create another subview. File private struct, remaining time text, remaining time view. This is view. So now I can use this view model in here for the timer. I think I already had this. Yeah, it's just time remaining formatted. Then in my inspiration view model, I don't want to use this directly. I use now the subview, which is this remaining time view. And I need to add the list raw background outside. Okay, now when I start my timer, these raws don't change because it knows now this view doesn't need to update itself just in one of the subviews. So this one is recreated. The one that I actually need. So on the one hand, having this environment object for all your app might sound like a bad idea, but on the other hand, you see here, I just create sub-views where I actually need it. These ones are probably updated quite a lot, because now even if I change here one of these data points, these are updated, but because it's a text, it's so cheap that I don't mind so much. And yeah, not like the images, which cost me a lot of calculation power. So just using here sub-views is great, because it's in the environment. I don't need to pass it down from one view to the other. That would be very bad. If I now would have, again, passed it here as an observable object, then this view would have been evaluated in this one. So instead of passing view models around from view to view, which cause all these updates, using just the environment object actually the better strategy. This is also good, for example, if you have a view modifier where you need to use data. Print fetch something in the view model. Okay, maybe in this case it's not the best, because maybe in this case it doesn't really make sense, because I'm already here using this view model. So let's say I want to add the tap gesture when I am tapping on one of these images. So I would need to attach it here to this image. How do I get rid of? And in this case, I would need to again call this view model. I don't want to put here this view model again. That would be another problem. And in this case, you can use struct view modifiers, because in view modifiers, you can actually access the environment again. So this is my custom view modifier, view modifier. We have this body function where you get the content, and now here I can attach something like my tap gesture. And view modifiers are allowed to access the environment. So I can call this here and then again use the more data function. Now I can add this modifier here. Okay, if I tap on this image, you see I am here getting my print statements, but my rows don't update. This is because it only goes into this view modifier. It doesn't actually change the image. It knows that this image doesn't depend on the view model, so it doesn't update it. But this is another little trick if you need to reduce dependencies. Use a lot of, if you have one environment object that you use everywhere, instead of passing it or the view model around, just use it here in view modifiers or in very cheap subviews. And then check which views are expensive to recreate, to call often, like if you have images or you calculate something, some string interpolation stuff, some fetching, filtering. These views try to reduce the dependencies that would update them very often and create subviews, very simple subviews that are cheap to recreate. I should have actually recreated another view, so I'm just going to refactor this, rename this, and add another one, ObservableObject reduced dependency, and then one original version, so you have something to test with these two different ones. Okay, as you saw, I can refactor my app to see which dependencies you actually need, but this is a little bit annoying sometimes, because it will slow down your progress and you have to do this oftentimes, and then maybe you change something in the app and it doesn't work again. So this is the disadvantage of this strategy. Now, if you have a view model like I have here, and you want to minimize the updates that happen to this view model, we can also use a view model wrapper. This is the next version of this, and I'm directly creating a subview for this. Another file for this. This is ObservableObject wrapper example view. Just going to copy the same from the first with this view, just a different name. Let's have a look at this view model again. This view model works for properties that you have here that are of value type. My nature inspirations is a struct. If I would have used here classes, the updating wouldn't work properly. The reason is because it uses here a did set, or no, will set or did set, I don't remember. Every time one of these properties changes, one of the observable object publisher stream or this data stream, there's the object will change publisher. This will fire, something changed in this view model, and then the views get updated. Because I use here did set, if I change a property in an object, this will not be called. With struct, it will. And we are going to use these fact to our advantage. I'm creating here a new file, SwiftUI view. This is just use the same name, inspiration view model wrapper. This is actually, I don't need SwiftUI, I only need foundation. So this is a class of type ObservableObject. And the only property that I'm using here is var view model. And this is the actual view model that I have. Now let's see what happens when I replace the view model with the wrapper. Just copying the name. So I have the view model. Now I'll use a wrapper here. Okay, now it's complaining in a couple of places because the data is not there anymore. This is not the view model itself with the data directly. This is in the view model. So the view model's view model. I should definitely rename this in a second. This is the view model's view model. Then I'm appending a new item in the view model's inspiration. When I toggle this, I need to call the view model's toggle timer function. The time remaining that I'm showing is in the view models. And then down here, it's also the view models. Okay. And last, I'm just going to rename this to view model wrapper. Okay, nice. Now we can actually see and test this. Okay, let's add one more row. And you see nothing happens. This is because, as I said, the data that is used here, what changes is a property in an object. Because this is a class, if anything in here changes, the did set of this won't be changed. And actually I also need to add here add published. But even then it won't help. I press add more and nothing happens. Nothing updates. It will only update if I actually set a new view model, which I don't do. So I'm removing here the add published because it's not true. So now I actually broke the whole data flow of SwiftUI. How do we get it back? So I have now the opposite problem. I update not enough. How do I get this back? By creating subviews that rely on the observable object that works with the data correctly. For example, for this view, I create a subview. So this I want to refactor. Similarly to V4. This is the inspiration list view. This is a view. Now the data that it actually needs is in the view model. So we could just say this depends on the observable object var view model, which is my inspiration view model. So show this view model's data and then also pass this view model. Now if I use this list with the view model wrapper view model. Okay, if I now change here and add one element, you see it's finally updating again. Also when I change here these titles. Just to get a quick reference, I'm adding again the random color background. Now when I do this, all my rows are updated again. This is because here again I'm relying on this view model. This is because this view model is still directly here passed down. But in this case, because it's an action call that I actually need, I might as well pass the wrapper itself, because that one is not depending, or this one is not updating. So this one I could pass easily around and wouldn't cause any updates to happen. So this is a var view model wrapper. And then I also pass this then to my raw view here, instead of the whole view model. Okay, now I have a couple of errors. So here I need to pass in more things. The view model wrapper. View needs the view model wrapper. And in here, I don't call the view model, I call the view model wrappers view models fetch data. Okay, if I add one more, it works now, and nothing of the other views is updated. Same if I change here this timer. nothing updates also, but my timer doesn't update. Here I still have the same problem because again, it's a view model's view model. It doesn't update. So again, here I would need to create a subview. This is a file, private struct timer view. This relies on this view model here. And because this time I use the observable object of the view model with the direct data, this will update. So now in my main view, I can call this with the view model wrappers view model. Okay, now when I tap this timer, this here updates properly the subview that I created, because this one is directly subscribing to the view model that has the data itself. Whereas the other views here, this one is only having the wrapper, so it doesn't see the updates underneath. And still with this strategy, I have here the correct updates around. It's just a little bit more complicated because you need to now pass in the wrapper and you need to create more subviews. But again, it's a very good strategy if you have a complex data, and this wrapper you can pass around as much as you want to. You could also in here have multiple subviews with different data sets inside that you want to pass to certain views. So you don't need to pass always the full view model with all the data. You can have multiple of them here and then have wrappers and then only pass what you need. It's probably not the most straightforward strategy, but having this wrapper is quite good, especially if you use this in an environment as an environment object that you need to use quite in a lot of different places. If you're lucky enough to develop an app for iOS 17 and macOS 14, you can use the new observation feature, which greatly improves the updating cycle, because instead of when you have a dependency on the new observation feature, like here my observable object with the new one, we have a dependency in your views. The body is only called when a property that I'm using here is changed, not any property in the view model, only the ones that you actually use. So I don't need to rethink of what I'm actually passing here anymore. This is obviously my preferred strategy because then I don't need to refactor or rethink anything. But as I said, it's only available for the newer versions, and we need to program our app a little bit different. So first, the data that I'm using here is not a struct, it's an observable class. So we need to create a different version. For our data, this is a Swift file, observable nature inspiration. I need to import the observation API. This is a class inspiration. And I need to mark this here with an add observable. Now I have to use the same properties as before. So this is name, image name, and description ID. Because this is now a class, not a struct, I don't have a default initializer anymore, so I need to here just create my own. And I also wanted to have here some dummy data, where I need to change the name to the proper ones. Okay, I need to change the models. The good thing about this, if you at some point decide you need to have a database, you need to store it on device, you can change to Swift data and change this here to a model. And you're quite quickly having a data storage. Now I also need to change my view model in the same style to it's observable. And just the last thing is I need to add here identifiable. Okay, this is the model file that I changed, and I need to also change my view model. So this is a new view model file version, observe view model. Obviously, you would have much more interesting names in your real app, but I have here multiple versions. So import observation add observable class observable view model. And I'm using the same data. So let's just copy the whole content of my existing view model. Now that we're working with this, I don't need to use add published. And the data here that I'm using is also the newer one, observable nature inspiration examples. This and cancelable is because I used here combine to do this timer, because this data is also a class. I have a view model class with data inside that is also a class. This data stream still works, so you don't need to worry. It's not like the observable object where this is a problem. Now let's use this in a new view to see the magic happen. Observable view. And I copy the all existing data from the bad example. So my data now depends on the new observable view model. And because it's observable, we don't use this state object, anything object, state object, observable object, environment object anymore. This is simply state. So you don't need to have distinctions anymore. This is just state. I use this in this raw view, and this is because the data is different. This needs to be now observation, nature, inspiration. And the view model is also the new one. Again, I don't use here observable. If I need to change something, which I don't here, I use a bindable, so this one, but I don't, so I can just do this. Does it work? And then, and I here add a new one. So this is this example function just to create a new one. Again, with this new type, going back to the observable example view. This is now in the observable nature inspiration data example. So the types match. And I should also add here my color and this print statement. Self.underbar print changes. Okay, let's go to live preview. I add one more element. It is added here. I have one new raw created. Add more. Here's one more. The weird thing about this print statement now is that it gives me a self changed. This should actually, because it's a new raw with a new identity, I thought this should be an identity, but it's a little bit different because the data flow is different. Then maybe I change the title here. In this case, we see raw view at dependency changed. One dependency of this raw view changed that caused this. So one property that I used here is changed. I don't see which one, unfortunately. In this case, I know it is here where I used the inspiration name, which depends on this inspiration. This is a class observation. This is a dependency to this view that changed this. And as you see, the information is not as rich as for observable object. Maybe this is going to change. But at least here with my colorful backgrounds, I know what's going on. Then let's also test this with this toggle timer. This updates, but nothing else updates. And my list here doesn't update. This is by far the easiest way to do this. And because we don't stop at this point, let's just use this and run the app in instruments. So I changed the main app to this file. I here press again profile in instruments. And then start a new measurement. Let's just use add more. Stop. Zoom into the area where I did something. And now I have here one time this observable example view is checked and one time this raw view is. This is this one raw that we updated. If I go to the view body property to search by my module, I actually see here there's one state object that changed and caused this. Yeah, it's a little bit different the way you see this information with the new observation feature. This is also another reason why you would go for more sub-views. Because, for example, here for SwiftUI, if you use simple types like a string, you directly see what changed. Binding to a string changed for text field, and you see the new values. If you use simple types, you see more what actually changed, what the new values are, what happens, instead of this very complex view models here. I know that people don't really want to have so tiny subviews. If it's a reasonable small view structure, like here, instead of having these lists, 2 lists inside with this HStack, I would probably at least create 3 subviews here with this data so I see which parts are changed. Now I also wanted to hint to one issue that I found with the new observable feature. So if I have here this app running on macOS and I add another window, This now should have two different data sets. Unfortunately, the view models or this observable are connected. So for example, if I start the timer in one window, it actually should only change this in one window. But you see both of them are changing. And when I stop this in the other window, this one is also updated. If you have an app with multiple scenes, and these are called scenes in SwiftUI, that have different properties that you want to use in these classes, you will share data. And this is definitely not what I wanted. I tested this for macOS for different Xcode versions, and I also tested this for the iPad in split screen mode, where you have two scenes running. And I also see that it's shared there. So I don't have two independent states, which is really defeating the purpose, because I want to use this, for example, for a navigation split view where you select an item in a list, you want to show the detail. This selected state should be in this view model, but because it's shared between the two instances of my app, both in split screen mode, both of them show the same selected item, and that's definitely not what I want. Not sure if they changed this. I don't know if this is intended, and I didn't find anybody talking about this. So yeah, you can test this yourself. Just want to let you know there is one drawback. Not that you implement everything and then you realize something is going on, like I did. Lastly, I want to show you a little bit more of a complex app, just to demonstrate some other things and implications. This is a little snippet app a screenshot app that I made as a demo project. It grew up a little bit more than I intended, and I'm going to do another video series where we're going to build parts of this again. So let's see how this is running. The current version is actually improved. I just added one more thing to make it worse again. And as a first test, you can also use directly in Xcode the CPU measurement. Okay, I have now this app, and I open a new canvas. Probably make this bigger. Okay, I have here one Xcode screenshot and another couple of other images. For example, to highlight something, so you can drag and drop in more images and assets. And because I wanted to also be able to edit this stuff here, I added a inspector area on the side, and you can just edit this here. So for example, we can do rotate this, magnification. This is also with gestures. When I open this area, I did this with, you see here with this animation, and I shared a lot of state, because this selected image or this selected layer, I also want to be able to do from my main canvas. So when I double tap here, I also want to open this, or double tap here, I want to go to the other ones. So I need to share this state around in a view model. That was the idea. At some point, things got a little bit too intense, and every time when I opened this didn't animate properly, it was stuttering. One of the reasons for this problem is probably I used very heavy images that I used here, and maybe I should compress them. But it's also because I updated all these views a lot. You already can notice here that my CPU usage is a little bit high. So this is a first indication of something is going on. Now let's have a look in instruments. Because I have here more complex app with a lot of views, let's see if we can identify the view that makes so much problems. So I profile SwiftUI, starting this measurement. I do the same, I open this canvas, and then just want to open one of these editors. So this is the action that caused previously so much work. I stop. Now we have here already more things because I did more. So for example, I can zoom into this one. I can also check the other ones to see how intense they are. Usually what I look into is, for my app, how long is the time duration? This is 10 milliseconds. Before, for the other simpler app, it was 1 millisecond. So this is a lot heavier. And I have here 36 views that updated. Now I open this, and you see this is quite a view. So where do I start? I tap on the total duration to sort this by what's taking the longest. And you see 8.5 milliseconds is used for this layer preview, which is created 5 times. What is this layer preview? when I select here one of them in the sidebar and I show this list, the preview for each of this image that I use, or this cells here, this is called layer preview. So I have here, in this case, 4 of them in the list. And then when I press here edit, I show the small one and I use the same layer preview here again. So in total, I have this one that should come up new and then 4 that already exist. But you see here, instead of just recreating one new one, because this is the one that comes on top, I have here 5. 5 for the existing ones. So when I press here, the other 4 also updated. This is really bad because, as I said, maybe my images are a little bit too big. I already optimized this, and you could say now, yeah, you just use smaller ones. If somebody else uses this and puts a couple of really way too big images in here, then my thing is going to break down. So I need to anticipate working with really large images, or a lot of them. I did some stress tests. As you see here, I added quite a few of them. Then are also a little bit larger and heavier, just to make sure that it also works for this ones. You can try. You don't see anything lagging here, even though it doesn't seem like a problem now. You never know what happens in the future when you add more data, more features, more updating here. Things get a little bit too crazy. So this updating here, in this case, it's definitely too much. And what you can do, as you said, in instruments, you look for the total duration, the one that takes the longest. In this case, it's 90% of my app is occupied by this one view update, or this 5 updates, where 4 of them are unnecessary. So I could decrease my app's footprint. So that would be great. Now let's look at the view properties in my module, because I have so many views. This is difficult, so I filter again for the layer preview. So I see here I have this 5 views, and I use an environment object. This is because this window state holds a property for the selected layer. Going to this view, this is the one I actually included again. I don't use it in here right now. So let's remove this. Test this instrument again. It's usually a good idea to go in the same canvas where I did this before. So I have here my 4 images. I open the editor. This is the action we wanted to test. I stop my measurement. This is this part and my view body. Now my app only takes 3 milliseconds from previously 11 or 10. So you see this is 30% reduced. Great job, me. Then I look here, and the heaviest view creation is the layer preview again, but it's only recreated one time, as I expected. In some cases, you might have multiple views that you need to recreate. Then it's okay. You just need to think of, is it really necessary to recreate this view this many times? That is so expensive. If I have a text view that is super tiny, or a button here that I use to refactor that is recreated 5 times, but only 17 microseconds, this one I don't care so much. So just focus on the really heavy ones that make a big difference to your app's performance. Like here, this image view. You can also check this in the view body property again. And I don't have this anymore. As you see from this more bigger project with a lot of views, using instruments is really advantageous, because now I know which views to drill down that influence my performance. So if you have a performance issue, your app gets slow, stuttering, you start with instruments to find the views. Then you use more of these debugging tools that we had with the colorful backgrounds or the print statements to test and fast change something. And then in the end, you go back to instruments to really check how much you improved. And you can directly see multiple of these measurements, comparisons. For this app that you saw here, the more complex one, I actually didn't use the new observation feature, because I said I had this problem of shared state between windows. Maybe this is going to go away in the next ones, but I wanted to have multiple windows, so I used more of the strategies we had before with the reducing dependencies, where I use it with an environment object as in smaller subviews that are really cost efficient to recreate. This more complex project, maybe I should actually say one time what it actually does. Let's say you're in Xcode and you want to share something, you create a screenshot, you drag this in the app, you change a little bit of the background, and some fancy colored background. scale this, maybe also clip this to this area. And then add some other images, the ones that I have here in this assets already. Like change the color of these because these are transparent these are transparent PNGs. And then arrows, although people made already fun of me about being excited about having arrows in there. Then you can generate here this image and drag this image, for example, on the desktop, and you have a nice image that you can share on Twitter or LinkedIn or somewhere. There's already apps existing that do this kind of screenshot editing. This is in itself not super innovative, just adding a background and stuff. But I started it because I thought it was a cool demo project to rebuild and practice a little bit of a lot of things that you need in SwiftUI, like here this navigation split view, working with images, doing some fancy gestures like scale, drag gestures, working with images to change their colors. Okay, this one doesn't really work because it's full, it's not transparent. Changing here these images, foreground color if you use a different render mode, for example. And then you need to also do quite a bit about resizing with geometry reader. So I have here properly the resizing of all these elements on their position and these corner radius, adding shadows and this kind of stuff. So it's a cool test project to really practice things. If you want to rebuild this little screenshot app with me, don't forget to subscribe to this channel so we can work on this together. But before that, I'm continuing the series of improving SwiftUI performance and bugs. So in the next one, I'm going to talk about how view identity influences how SwiftUI updates and works. And this is in relationship to the identifier protocol, what you should do and what you shouldn't do. So also watch that one because this is a very important concept to nail in SwiftUI if you want to have a great performing app. Don't forget to like this video. Until next time, happy coding.